Welcome to the Royal Observatory in Greenwich here in London. Tonight's programme is all about the moon and we'll be finding out about the latest mission to go there.
We'll also have the results from this summer's More Moon Marathon. I know lots of you have taken part and I'm really keen to find out how you got on.
Later this evening we're hoping to catch a glimpse of an intriguing lunar eclipse. But until then, here's Pete Lawrence with what to see in November's night sky.
Astronomers are getting excited about Comet ISON, which is starting to produce a tail as it nears and gets heated up by the sun. At the start of November, the comet should be visible in binoculars close to the star Sigma Leonis, which marks the rear paw of Leo. It passes very close to the stars Xavi Java or Beta Virginis on the morning of the 7th of November, and Porrima or Gamma Virginis on the 13th. On the 18th, ISON will be very close to the star Spica or Alpha Virginis. The comet should be visible to the naked eye at this time. With binoculars pointed at Spica, you should be able to pick up the comet in the same field of view. As we head into the third week of November, the moon gets in the way, and the comet is only visible in the morning twilight. One more thing for you to look at in November, the planet Jupiter, which is in the eastern sky. Throughout November, it's located close to the star Wasat in Gemini, the twins. The charts to find the comet and Jupiter are on our website at bbc.co.uk/Sky at Night.
This month's Sky at Night is from Greenwich, with astronomers converging on Blackheath Common. Chris and I have been joined by Pete Lawrence and John Coleshaw to see the lunar eclipse. What better time to announce the final of our More Moon Marathon? Sir Patrick Moore, as a young astronomer, studied the moon.
I think the first explorers may have some surprises when they first step out of their craft onto the barren, bleak moonscapes.
He spent thousands of hours building up lunar maps, which were later used by the Russians and Americans when they went to the moon.
Well, you can see the dark seas even without a telescope at all. Because after all, the moon is by very much our nearest neighbour in space. Our nearest natural neighbour, that's to say.
Patrick always encouraged us to look up and appreciate what's on our celestial doorstep. We've tried to keep the spirit with our More Moon Marathon. Okay. While Pete and I assemble our table of wares, let's get the results from Chris and John.
Well, it has to be said it's not the clearest of nights right now. We've got plenty of astronomers. They're looking cheerful and enthusiastic and hopeful, so fingers crossed.
Yeah, they certainly do. And one or two breaks in these clouds which are giving us that sense of promise. We might see a good view of that penumbral eclipse later.
Let's hope so. But before we get to that, let's talk about the More Moon Marathon. We challenged you back at the start of the summer to take a close look at the moon, and thousands of you have taken part. It's been wonderful to see people's enthusiasm.
Yeah, some terrific comments here. Simon and Sarah Fisher from Worcestershire had a great deal of fun over the summer, lots of clear nights. They had a really lucky run at it actually, and were able to go through all of their moon captures in great detail, so a sense of the dedication there.
That's right, the waiting for clear skies is a bit of a theme. Chris Good from Devon says, it took me over a few months to get all the information due to rubbish cloud cover where he lives, and I sympathise with that myself.
His dedication carried him through. A nice one here from David Winham in Newcastle. Looking at the moon, I had a feeling of intrigue and desolation, maybe magnificent desolation. Maybe I become moonstruck. I think you have, David, and we're glad of that.
Also moonstruck, Victor Suttle, who I think must be the youngest person to take part. He's 5 in Essex, and he says, I spotted the half moon, and it was really tricky, and it took me a long time, but well done for persevering.
Exactly, half a moon is better than none at all, so well done for that.
Is that true?
I think so.
Good.
I think so.
Okay, we'll settle for half a moon
yes.
tonight, I suppose.
There it is,
yes.
Through a little bit of hazy cloud. See, these are the little glimpses that give us promise and hope.
It did vanish while you were saying that, John.
Yes. Keith Moore from South Yorkshire enjoyed this, very much enjoyed the Triple M. Going to make it my quest to learn more about the moon just like my namesake. Well done to you.
Well done indeed. And the Kilgore family from Glasgow took part in the Triple M, as I think we're going to call it from now on. And in particular, Alistair, who enjoyed it so much he had a moon birthday cake. So you can not only observe, but eat all of the features. So well done, Alistair.
A wonderful award-winning cake that
Indeed.
was.
Well, we'll come back to the Moor Moon Marathon in a minute, but first, let's look at what's going to happen tonight as Pete and Lucy explain the eclipse to us.
It's gone again.
Tonight's eclipse is slightly different, slightly unusual, and it comes down to the fact that there are two parts to the Earth's shadow, and you can illustrate that on the table here.
I'll have a go. There we go.
So you've got the light passing over the Earth and coming on the table, and what I can see really clearly, there's a dark centre to the shadow that we call the umbra, and then a slightly fainter shadow all the way around the edge that we call the penumbra. So Pete, what is it that's happening tonight?
Well, tonight the moon will be moving through the shadow, but it's missing the main part in the middle, and it's moving through that outer fainter part, the penumbra. So it's what's called a penumbral eclipse of the moon.
So it's coming through here, is it?
Yeah, that's right. Now, I think the best way to describe a penumbral eclipse is to call it a subtle eclipse, because if you were looking at it visually, you probably wouldn't see much difference in the appearance of the full moon. But if you take a photograph before the moon enters the penumbral shadow, and then another photograph of the moon when it's actually in the penumbral shadow at the maximum part of the eclipse, what you see is a very gentle shading close to the bit of the moon which is closest to the darkest part of the shadow in space.
But still, it's a very special event, and it's one that I'm looking forward to seeing.
Our marathon has been divided into 5 sections, and the first is all about the lunar seas. We've been joined on Blackheath Common by moon expert Katie Joy.
Several people, including Paul Kus from Poland, wanted to know about the seas, wanted to know how they formed. So, first of all, why do they look so different from the rest of the moon?
So on the moon we have 2 main rock types. These are my fake moon. I'm not allowed to bring huge chunks of real moon out with me.
It's a shame, really.
It is a bit of a shame, but essentially we have 2 main rock types on the moon. We have a white rock in the lunar highlands. This is the very old rock. And then we have lunar lava flows that were formed in volcanoes, and these are the material that formed those dark seas that cover most of the near side that people have been spotting in the Moor Marathon. So this is the reason we have the seas, lava flows.
And so they're made of different stuff, and so they're different colours?
Different colours, different chemistry, different minerals between the two.
The lunar seas appear to be a lot smoother as we look at the moon. Is that true in reality?
The lunar seas are a lot younger, so we have to go back to the origin of the moon to sort of talk about its early geology. We think the moon formed at about 4.5 billion years ago in a giant impact event where a Mars-sized body crashed into the early Earth. It spawned off a huge amount of material and formed a magma body in space. And then that magma body cooled and it formed an interior, a core, a mantle and a crust. And so the crust that formed was made of this rock, which is the very old Highlands material. Subsequently to that, we had the lavas that were formed deep in the moon, propagated through the crust and erupted into large impact basins that are on the surface. And the reason they're so smooth is because the lavas were very runny. They ran out and distributed very evenly across some of these types of impact craters, making a smooth surface. And they also haven't been heavily impact cratered like the Highlands because they were a lot younger. So it's kind of a twofold reason: less impact craters and smooth runny lava that made them.
Is this very different to the formation of other moons in the solar system, to around Saturn and Jupiter? Mars's moons, we hear, are captured asteroids. So this sounds rather different.
It's a unique event. Yeah, most of the other moons we think of are captured from bodies moving in and then being gravitationally attracted to their parent planets. But so this is why the moon is so interesting. It's a completely unique event, and it tells us lots of information about how the Earth formed and early terrestrial processes as well.
And also, because it's old, it's a record of the early solar system as well. And there's some interesting results that come from counter craters and look at these older surfaces.
That's exactly why the moon's so important. It's 3 days away, it's very easy to get to, it's accessible, it's 4.5 billion years old. Well, if you've got a big spaceship you can get there in 3 days. And it provides us with a record of the geological evolution of the inner solar system over 4.5 billion years. So much of that record has been lost on the Earth because we recycle our geology through plate tectonics and other types of active geological processes. But the moon is almost frozen in time. So the moon's really special for lots of reasons.
And the lunar seas that we were talking about, what a great starting point they were for the marathon. Great naked eye objects just to get you in there and lead you on to the others. Philip Jennings of York, he was saying that the seas are a wonderful sight with the telescope. They certainly are, especially when rippled with wrinkle ridges or crisscrossed with brighter crater rays at full moon. A shame then that he locked himself out of his observatory because he couldn't find the key. Oh dear. But this did remind him how wonderful the moon is to see just with the naked eye, which is very true.
It is wonderful, and there's no sign of it whatsoever. So we're going to go to Pete at Lucy to find out how some of the craters on the lunar surface formed.
Now we're moving on to the second part of the Moor Moon Marathon that looks at some features on the moon that reflect its more violent history. These are craters, bright and dark craters. So Pete, why did you choose these features?
Well, these are features which are easy to see when the moon is fairly well illuminated, and I think they're pretty iconic actually on the moon's face. There are very bright craters with very large rays coming off them, and also dark craters which look like little lakes, if you like, of lava.
These are features that you perhaps need to have binoculars to see, so they're a little bit more challenging than the first section of the Moor Moon Marathon.
Yeah, that's right.
Now you mentioned rays, features of craters. We have a tray here. Now you have a challenge because you can make a crater.
Okay.
We've got flour underneath and cocoa powder and chocolate on top, and this is the asteroid.
Now I've got to make this work. I've got to throw this hard into the tray. So
I'm going to step back.
Okay.
Go for it. Oh, perfect!
Wow, look at
I mean,
that.
that is fantastic. So you've carved out the crater floor here.
Yeah.
Absolutely fantastic. And all the bright material underneath has come into
up,
view.
That's right. So it's gone across the dark floor of the sea there. So this stands out as a ray crater.
So this would be a bright crater in Amari on the surface
That's
of the moon.
right, yes.
Beautiful. And I can see the ejector here.
Yeah.
And these would be the bright rays.
That's right. Well, Tycho is a great example of that, of course, in the southern part of the moon, because it's got those bright rays which extend right across the moon's face.
It's an iconic crater, isn't it? And a lot of you really got excited by Tycho. So I've got a comment from David Winham from Newcastle. And he says, Tycho is spectacular to look at. The impact crater is so vast, which scars the moon. And it really does. It spreads them over a huge distance.
It does.
I think that's my favourite crater to look at. But this comment is lovely from Alan Fenner on the Wirral. He says, if the moon was a giant fruit, Tycho would be the place where it hung from the tree. Beautiful. So this is a really lovely example. Now, you had bright and dark craters on your list. So tell me a bit about how the dark craters form.
Well, the dark craters, like Grimaldi, which is a very distinctive marker on the moon's face, is basically a crater where the floor of the crater has become flooded with dark lava. And they look very, very distinctive on the moon's face.
Pete, the craters you selected, they're all beautiful, but is there one that stands out as your favourite?
I think Copernicus, actually, because that's a very well-defined crater. It's got great rays coming off from it.
Just like this.
That's right, and it's got these beautiful terraced walls when you look at it. They're all sort of blocked down to the floor of the crater.
And actually, you can see that we have got that effect
it does
in
look
our
like
crater
it, yeah.
here. Little terraces, and that's formed as the lunar surface slumps back down again.
And Copernicus has got some fantastic mountains right in the centre of the
So
crater.
in the largest craters you get this central uplift as the rock becomes more sort of plastic.
Yeah, like a liquid, and sort of comes back up and then solidifies.
Well, I've got some more comments here that includes Copernicus.
Okay.
And it's a comment from David Scanlon in Hampshire. And he says, Copernicus and Kepler, clearly obvious due to their size. Aristarchus, stunning, brightest lunar feature by far and awe-inspiring. Now, Aristarchus is an interesting crater.
It is. It's a very young crater, very bright. It's got those terraced walls again and very bright rays around it.
So go to the website and find the location. And we've got another comment here from Sammy Glastonbury. Kepler reminds me of a spider.
Okay.
Do you see that?
It's never reminded me of a spider, but it might do from now on.
Another comment here from Sarah and Simon Fisher from Worcestershire. They said it was awesome to be able to use our own photos and name both the bright and the dark craters, which is just wonderful, isn't it? It really sums it up. Now, section 3 is craters in shadow. We've got a nice demo here to illustrate just how fantastic these craters look.
That's right. Well, the reason why I wanted to put these into the More Moon Marathon is that the craters are really dramatic when they're very close to the terminator, the line which marks the difference between night and day on the moon. And I can illustrate that with the sun again.
The trusty sun.
The trusty sun, and these fantastic models of craters. In fact, if I illuminate this crater from above directly, you don't get to see many of the relief features, the features with the height on there. But as the sun's angle starts to come down, if you watch what happens inside it, you can start to see the shadows growing in length. Those craterlets have really become well defined now.
Yes, you're absolutely right. I can suddenly see all the structure within the crater itself.
It's amazing. And look at the length of those shadows as the sun starts to get lower and lower in the lunar sky. Look at the central mountains there.
Gosh.
Those mountains look enormous because they have this huge triangular shadow.
There's suddenly huge drama to that crater.
Yeah, that's right. And then suddenly it goes into complete darkness.
Well, the eclipse is now well underway, and there are probably people who are enjoying a good sight of it. And if you could see the moon right now, you would begin to notice a difference from an everyday moon. We can't see anything. So let's talk about the lunar surface again. And in particular, David Scanlon from Hampshire talks about Clavius, a wonderful myriad of younger craters over an older crater, which makes for superb exploration.
Yes, they really captured the imagination, these, didn't they? The craters in shadow.
Yeah. But tell us some more about Clavius, Katie. There's a complex history here.
So Clavius is quite a large crater. It's about 225 kilometres in diameter. It has a rim around the edge that marks its exterior extent. We don't know exactly when the crater formed, but we can count other craters that have been superposed on top of it. And so we think that it's Nectarian in age, which is about 4 billion years ago.
And because we had other craters in shadow as well, what about Eratosthenes? I think that's how you, is that how you say it?
Eratosthenes,
I think
is
so,
that it?
yes, that's the elegant way of doing it.
Very good.
Yes.
We'll let John say it. There we go.
Eratosthenes. Well, Alan Fenner from the Wirral, when I see Eratosthenes, I can't help but see, I love these imaginative descriptions, I see the eye of a baby dinosaur with the Apennines as its neck and back. Probably a young Polacanthus by that description.
Yes, very good. But actually, that mention of the mountains as the ridge of the dinosaur's back in that case leads us on to section 4, which was majestic mountains. And we had all sorts of comments. Keith Moore from South Yorkshire just says, Monte Jura on the Terminator, wow, which is a nice comment. Yeah.
Wow. Makes you think of future lunar mountaineers who could probably climb the mountains rather easily with that lower gravity, just floating up there. And it wouldn't be quite so bad when you fell back down again.
It'd still be a long way down, I have to say. But the mountains are spectacular. They might not be as high as our mountains on Earth, but they look wonderful. And Callum Kilgore saw the line of the Monte Jura disappearing into space through binoculars. And then later on saw the whole semicircle of mountains through the telescope, thanks to his dad, who got the telescope out in front of the neighbours. So well done, Dad. I think that's the main takeaway from that one.
Got the whole street talking.
Indeed.
Over Blackheath in London, the clouds have firmly set in, but in Pennsylvania, they had clear skies. The subtle shading in the bottom right of the moon is the Earth's shadow. In Massachusetts, a plane passed over the penumbral eclipse, and in Iran, you could see the Earth's shadow quite clearly. There was a handy gap in the clouds over Stuttgart, just enough for a glimpse of the moon.
Now it's a break from the moon and off to the planets, where we join Paul Abel, who's been finding out about the latest research results.
Every year, astronomers who study the planets gather to share ideas and their research. It's the turn of London, and University College London are the hosts.
Well, look at this, isn't this stunning? This is a beautiful panorama from Mars. It was taken by the Mars Reconnaissance Orbiter spacecraft, and it shows the beautiful, majestic ravines and the wind-swept sand dunes of the red planet, and it really is an incredible image.
Research is presented on posters, which are put up for everyone to look at.
Some of this is rather technical. Well, look at this lovely poster. This is about an extrasolar planet. And this is really a sign of the times because we haven't just got results here from our own solar system, but we have data from other planetary systems as well.
News from our solar system is always exciting. Mike Brown is here to talk about the latest from Jupiter's moon, Europa. It seems the oceans of Europa have salts, not unlike our own. Mike is more famously known for discovering lots of Kuiper Belt objects, such as Sedna, Makemake, and Quoll. Their exotic names give an air of mystery to objects that lurk in the farthest regions of our solar system, well beyond Neptune.
I shall introduce you to our viewers, if you don't mind, as the man who killed off Pluto. That's a fair thing to say, isn't it?
I think that's okay.
Well, why did you do that?
You know, my usual response when people ask me is because it had it coming. But but really, I did it. I killed off Pluto sort of by accident. I was actually looking for something that I would think would be a 10th planet, something bigger than Pluto, some substantially sized object in the outer solar system, and by looking. We surveyed the entire region of the outer solar system and realized that not only is there nothing really substantially bigger than Pluto, but there are many things that are just essentially the same size as Pluto, which really meant that Pluto is not as special as we used to think it was, and it really never deserved to be called a planet.
So I see you're completely unrepentant about killing off poor Pluto.
I'm actually very happy about it.
These objects, they are what we would class as trans-Neptunian objects. That's a general umbrella term. In fact, we more often commonly call them Kuiper Belt objects.
They are the coldest, least processed objects in the solar system. And by processed, I mean, if you look around here at the Earth or any other planet, everything you see started out in the early solar system and then has been heated up and crunched together and extruded and split apart. And so it's very difficult to figure out what really things were like at the very beginning. As you move further and further out in the solar system, things have never heated up very much. And not only have they not heated up very much, they haven't been thrown around by the planets quite as much. So we can try to use what they're made out of and where they are to figure out not just what things were like in the very earliest solar system, but how things have rearranged since the solar system was formed. And that's really the promise of this region out beyond Neptune. If you could pick up a piece of it, you're almost getting a little slice of the original cake of the solar system, which is what you'd like to do.
That's quite a thought.
These distant worlds have volcanoes and water ice. They are far from boring and bland, they have geology, and some of them are large. Eris is about the same size as Pluto, yet it was only discovered in 2005. Could it be there is an even larger world lurking in the icy depths of our solar system, the infamous Planet X?
You know, so there's always the possibility that out in the Oort cloud, there's, people have always speculated about a brown dwarf or a Jupiter-sized thing. I think that these days it's harder to speculate about that because we actually have data that suggests there's nothing out there. But you can always hide them somewhere. So people will forever speculate about these Jupiter-sized things out there. I suspect it's not true. I think the biggest things that are still out there are going to be this, Mercury or Mars size. They're going to be very far away. They're going to be very faint, hard to find, and then hard to study. But I bet they're out there.
We have discovered around 1,000 Kuiper Belt objects, all in the past 2 decades. The first was found in 1992 by Dave Jewett, and is called QB1. Dave has come to London to talk about something new and to solve an old mystery.
So asteroids have been known for 200 years or something like that, and I figured it's all over. We know everything you ever want to know about asteroids, and it turns out that there's this population. It's been there all the time, but it was only just discovered. They are asteroids by their orbits, but they look like comets.
How confusing.
And it's very freaky because an asteroid you would think is a rock, and a rock looks like a rock and nothing ever happens and it's kind of boring, but actually they look like comets. They release material, they eject dust, and it's just very bizarre. So I'm trying to explore this population. We don't have many, there's like 10 or 12 known at the present time, but we're looking at these things, trying to understand what they are, and they're part of this general phenomenon that we call the active asteroid phenomenon.
Wow.
By which an object that you think should be just a boring inert rock somehow is able to be active and eject material.
The Geminid meteor shower graces our winter skies every year, and it's the asteroid Phaethon which creates them. Phaethon, it seems, is one of these new type of asteroids which acts like a comet.
Phaethon is in an elliptical orbit that goes all the way into 0.14 AUs.
Right, so it's quite close to the Sun.
It goes 7 times closer to the Sun than we are.
Right.
So it gets 50 times more sunlight than we get. So it gets really hot at perihelion. And in this particular case, what I think is happening is that it gets so hot that it cracks, it thermally fractures. Just like if you take a glass of orange juice, you drink the orange juice, you stick it in the sink to wash it, you hit it with hot water and the glass will crack because of thermal expansion of the glass. Probably that happens to the surface of this body.
So it gets really hot, and this
really
material just flows out, and this we think is responsible for our Geminid meteor stream later on in the year when the Earth passes through it.
Well, that's what I think.
Sounds like fascinating stuff. What sort of things do you hope to get in the future? What do you hope to discover more of these objects, presumably?
So we've found this zoo of very, very strange objects lurking in the asteroid belt, and we'd just like to understand what they are.
We live in interesting times, Dave. Thank you very much.
Okay, you're welcome.
There is always time for a spot of R&R at these conferences.
I bet Pete would be good at this. Oh.
No luck with my lunar rover. Houston, we have a problem.
Oh dear. That's why I don't drive, incidentally.
NASA had better not rely on me. Time now to go back to Blackheath Common for our last section in our More Moon Marathon, which Pete's called the Lunar Specials.
It's 1 in the morning here at Blackheath and we're still going strong. Somewhere there's somebody having a good view of the eclipse, which is at maximum about now, but it's not us.
Yes, we can't see it, but we know it's there. Completely overcast, but there's nothing one can do.
No, absolutely not. We should move on to the Lunar Specials. Christina Chester from Hertfordshire, who's here somewhere, found a migrating duck and a puppy with its bone up in the Lunar Highlands.
That's quite strange. Well, Richard Bailey from Daventry says, thanks to Mr. Coleshaw, I now see a Cyberman on the moon. I know how he feels.
Sorry, I'm sorry. Sorry to ruin the old lady of the moon. I think she's more like the lady from Downton Abbey. I've rethought that one.
And Stephen Brown from Middlesbrough says the ghost crater Stadius was the hardest feature of the marathon for me, but I managed just about to make it out, so well done.
We also had some complaints about Rupus Rector. I think various people got lost trying to find this. Sammy Glastonbury said it was very, very, very hard to find, very frustrating.
Yes, Alan Fenner from the Wirral said that. He said other people seem to be able to get great views of Rupus Rector, but I always find it very difficult. A rumph.
Well done to everyone who took part in our More Moon Marathon, and especially if you managed to complete it. There is a cosmic congratulation to Wayne Young and his son Thomas, who completed all 3 of Patrick's observing marathons. Quite an achievement. Our guides on what to see on the moon are still on our webpage at bbc.co.uk/Sky at Night. You can also find Pete's charts to find Comet ISON over the next few weeks.
We've had a fantastic time here, so thank you to everyone who stayed with us. That's thanks to the Flamsteed Astronomical Society and the Baker Street Irregular Astronomers.
When we come back next month, we'll be heading for the clear skies of La Palma in the Canary Islands, hoping to find a bright comet. And so, until next month, good night.
The BBC Sky at Night, How to Read the Solar System, A Guide to the Stars and Planets is available now. Coming up later here on BBC4, powerful wartime drama based on a true story of heroic resistance. Daniel Craig stars in Defiance at 9.